Jai Hind to all. This is Santosh Mishra from IT department of Akgec. Today in this lecture we will study how the searching are performed through C programming, and we will cover the sorting. Basically I will cover three sorting: bubble sort, selection sort and insertion sort in today's lecture. First, let's understand what the searching is. As we all know that we are every time we are populating with lots of data. That data once stored somewhere, whenever required, we must have a way to search it out in a efficient manner. So there are different way of searching the elements in a stored data, but we will focus only two searching techniques, that is linear and binary searching. So firstly, searching means to finding elements in a given list, and if it is available with that list, we may say that the search is successful. Otherwise, if it is not available with the list, we can say that search is unsuccessful. So searching, we basically focus two types of searching. First one is linear searching. First one is linear searching. First one is linear searching and second one is binary searching. So what the searching is, we will as I have already told you that we are every time populating with a lot of data, and those data are required to search whenever we are looking for those data. So what the searching is, means searching is the process of finding an element from a list of element, and if the elements is found, then we can say that the search is successful, otherwise unsuccessful. So for example, if we have given this set of data and we want to search whether 40 is available with this data set or not. So we will keep on checking and comparing, and if the data is found in the list, we may say that we can see that the data is not available here. In linear search, we will first compare this data with the first element, then we will compare it with the next element, then we will compare it with the next element, and so on, and we can say that after checking up to the last element, we can say that the 40 is not available with this list, means we can say that this search is unsuccessful. If we are looking for whether 15 is available with this data or not, we will follow the same concept. We will look this 15 to the first element, then again we will look to the next element and next one and next one, and we can see that this 15 is available here. So we can say that this search is successful, means this data 15 is present at position 3, and so this search is successful. If the data is available, if the data is found, we can say that this is unsuccessful search. Otherwise, if it is not available, we can say that the search is unsuccessful. So there are two type of searching technique, as I have already told you. First one is the linear search, and in linear searching we keep on comparing each element with the desired element, and we keep on moving to the next element and comparing it, and if we find, we can say that the search is successful, otherwise unsuccessful. So this has been depicted over here. We have given a list and we want to search whether 13 is available with this list or not, and the linear search technique is that we will keep on comparing with each element, and we can see that this 33 is available with this list at this position, means search is successful over here. this is the way of linear. Linear means sequentially you have to check. You will compare with the first element, then with the next element, then with the next, keep on comparing with the next element, and we can find out whether the list is available, the item is available with this list or not, whether the search is successful or not. So let us understand what the logic of linear search is. We have the elements stored in array, and that array name is AI. A means A of 100 size array is there, or any size of array is there, and we have stored the n elements in that list. So to access each element of this array, we will start a for loop and start it with 0 index, I equals to 0, I is less than n and I plus plus, and we will keep on comparing the number, this number, and num is the number that we are looking for, whether it is available with this array or not. First, before applying this logic, we will populate this array with the given list, and by putting it in this for loop, we will keep on comparing it with the each element, whether the num I becomes 0, means num will compare with A of 0, then I becomes 1, num will compare with A of 1, I become 2, num will compare with A of 2, and so on. Means this num that we are looking for will be compared with each and every element, and whenever this becomes true, means whenever this elements present, means this comparison becomes true, means the element has found, that in that situation we have set a counter variable t equals to 0, we will change this flag to 1, and by break we will come out of the loop, because we have completed our task of finding whether this num is available with this array or not. Sorry. So let's write a code for this same logic. Firstly, I have declared an array of, let us say, 50 size, for where I will store the set of elements where I want to find whether the element is available or not. So firstly, this n is the number of element that we will stored in this array. So enter the size of the array, and this size has been stored in this n variable, means n number of element will be stored in this A array. So for storing those element, we have written this for loop, for I equals to 0, I less than n, I plus plus, and here I have scanned in the array A of I. I have scanned the elements, means user will keep on entered values up to n, and that n values will be stored in the array A of I. So now we will ask from the user enter the elements that you are looking for, that you want to search. So that element has been stored in this variable m, means we input from the user what element you are wanting to search, and that element has been entered by the user in this m variable. So after storing, we will apply the logic. Now we have the array with these elements, and we have the items that we are looking for. So what we have to do? We have to apply the linear search logic, and for that we apply this for loop, and here I compared this m with A of I. I will keep on changing. Firstly it will be 0, means this m that we are looking for will be compared with the A of 0. Now if it finds t becomes 1, means this flag that we have set to 0 will set to 1, and by break we will move out of this loop, and this I position of the elements has stored in a variable p that tells at which position this elements has been found. So whenever this comparison true, whenever this elements founds, the t will becomes 1, and by break we will come out of the loop, and this will only happen, this control will come here only when this relationship established to be true, and once it's true means we find that element, means our search is successful, and it will, as I have already told, this will be checked sequentially one by one to each element, and once it finds, then t becomes 1, this flag will change to 1, and after this loop by break we will come out of the loop, and we will check whether the value of t is 1 or 0. If it 1 means this condition true, means elements found. If found, now means we will write that element found at position p. So otherwise we will write in else part, we will write element not found. This way we can implement the linear searching. Now let us understand what will be the output of this code. We have entered the size of array as 6, and this 6 element has input as 8, 6, 25, 4, 15 and 7, and the elements that we are looking for is 15, that has been stored in the m variable, and if it finds in this list, it will be this element m will compare with a of 0 not found, a of 1 here it is not true, here 15 here is also not true, here it also not true, but here this comparison of if will becomes true, means it becomes true, the position of this element is 4. So the our program will say that elements found at position 4. Now let's see what the performance of linear search is. We analyze the successful and unsuccessful searches separately, as earlier I have explained. We also count how many times the search value is compared against the array elements, and successful search, for successful search the best case running time is one comparison, means we are looking the elements and that element found at the first position, array index 0 we found, we are comparing it with the first element and we find that, means the best part of the best running time of this linear search program is that it will be found by one compare only. So the best case running time is big O of 1, and worst case running time, the worst situation is that we checked by each element, and when we reach at the end we see that the element is not found or found at the last position, means we may have to compare up to n position, means n comparison has to be performed. So worst case running time is big O of n and best case is omega of 1. For unsuccessful search, the worst case running time is n comparison. If the elements is not found at that list, that also we have to keep on checking and comparing whether the element is not there, and when we reach at the end we concluded that the elements is not present in that list, and we will, so we can analyze that we have still the elements is not in the list, but we have to perform n comparison. So for unsuccessful search in linear searching you have to perform n comparison. Now let's move what the binary search is. What the binary search is, it's very important. The primary condition to apply a binary search is that your list must be sorted. Your list, later on we will see how we can perform the sorting operation, and once the list has been stored in the sorted form we can apply the binary search operation. So for applying the binary search, the primary condition is that your element, your list must be in sorted order. So let us understand what is the concept of binary searching. Let we have a sorted list, let us say 15 in the list, I have 15, then 17, then 17, 21, 41, 50 and 95, and we are looking this element. You can see that this list is in sorted order. So we will store it in this list in a array. We have stored it in a array, because this is a homogeneous collection. We may store it in a one dimensional array by the user. So this array is A, and we have 1, 2, 3, 4, 5, 6 element. Let this size is 6, and we are looking for item. We are looking to search in this list is that is for 50. We are looking 50, and we want to search whether this 50 is present in this list, and we want to search it by applying binary search technique. So how can we apply? Let's understand. Firstly, we also know that the first index of the array is 0. I have stored it in the first variable, first equals to 0, and last index of the array is last equals to size minus 1. If the size is 6, means if n elements are there, the last element will store to the n minus 1 position. If 6 elements are there, this will be stored at the index 0, then it will at 1, 2, 3, 4, 5, means last index will be 5. We also say the first index as lower bound and last index as upper bound of the array. So we will find the mid index. And mid index, to calculate mid index, we will find first plus last upon 2, and this index are of integer type, so its result is also integer. And here in this case, the first plus last means 0 plus 5 upon 2 will give 2, not 2.5, because first and last are integer, 2 is also integer, and integer upon integer will also results integer, means 2.5 will be truncated, this 0.5 will be truncated, and the result will be of integer part only, that will 2. So we find that the mid index is 2. So we will compare the item to be found with the element at the mid position. This index is index 0, index 1, index 2, index 3, index 4, index 5. So we find that the mid index is 2. So we will just compare this item, we will compare the item with A of mid index. We will compare it whether the item is present at the mid index or not. If it finds, we will say that the search is successful, item found at that particular position. But if this does not becomes true, means if this condition does not true, there are two situations. If the item that we are looking for, means at mid index, at second index there is 21, means search is not successful because we are looking for 50. So there are two situations. If the item that we are looking are bigger than this mid index, then we will focus on the upper half only. And if either the item is found at the mid position, if it founds at mid position, our task completed, means our search are successful. But if it does not find, that there are two situations. If the item is greater than this mid index value, then it will certainly be found at the upper half of this array. And if it is smaller than, we will, once the item that we are looking are greater than this mid index value, then we will only focus on the upper half of this array. We have not to do anything with the previous elements, because elements are present in that part only. So to do that, what we have to do, we have to move this first index value, this first will move to here, means first will become, means we will change this first equals to mid plus 1, the mid index is as 2. Now since the item to be found is at this upper half, so we will move this first to the mid plus 1 position. Now this mid plus 1, this will become the first index and this is last index, and we will again find the mid position. We will do it in the loop, so it will keep on performing repeatedly. So mid will be now again calculated, and mid is first plus last upon 2, means 3 plus 5 upon 2, and 3 plus 5 upon 2 will result 4, and it results 4. Again we will compare if the item that we are looking are at A of mid, and if it finds, and we can see here clearly that the item that we are looking, that is 50, and at the item at A of mid is now 4, means item at A of 4 is now 50, means this search are successful now. And we can see that only I have performed only 2 comparison, firstly here and second one is here. Every time you perform the comparison, your list will subdivided to the half part. Every time your bigger problem will be divided to the half one. So your efficiency of searching will enhance. So basically binary search are applied to the databases where the big data are stored. There are another concept like hashing also, and that may be also covered, but binary search is very much important. And if the item that we are looking are below this mid index value, then we will focus on the first half only. We have not to do anything with the upper half. If the item that we are looking for are below the mid index value, then we will focus on the first index only. Here we will have to keep mind, and for that we will move this last index to the mid minus 1. We will move the last will come here, last will become to mid minus 1, and we will find mid again by first plus last upon 2, and at mid we will find whether the elements is there or not, and we will keep on doing until the first does not become reach up to the last. When until the first is smaller or equals to the last, we will keep on doing it, and we will find the element at the mid position. So you can clearly see that this binary search algorithm is very much important and very crucial, very conceptual and very much important, and it must be implied by some programming. So let's understand it by some program. Before that, let's erase all. So now what the binary search is, if the array is sorted, then we can only apply this binary search when the array is sorted, otherwise we cannot apply this searching technique. So the basic idea is that first search the value at middle position. If the element is less than the search value, either it will be found at the middle position, otherwise if the element is less than the search value, then the value would be found in the second half, otherwise the value will be found at the first half, that I have already explained to you by the previous example. So we will keep on doing it, and finally we will find the element. Either it will be present, if it's present we will find that with lesser number of comparison at linear searching. As compared to linear searching, this binary searching is very much time efficient. So let's have this program that implements the same concept that we have just seen. I have declared an array A of 50 size. First is the first index value, that is 0, last is the last index value, that is the number of elements minus 1. Middle is the mid index value, we will find by adding first plus last upon 2, and S and N are, N is the number of elements. So firstly we enter the size of the array and we stored it in the S variable. So enter the elements and we firstly we declare the size and we enter this S elements into this array. So for entering, as we have already know, we write this scanf in the for loop, and by binding to AND A of I, we may input this number of elements to this array. Now we ask the user to enter the number of element that he is looking for, that he wants to search, and we store that item into the N variable. So after that we set first to 0 and last to size minus 1, means S minus 1, while, and we will keep on doing the concept that I have explained just before in this loop. I have written while first is less than last, we find middle index, middle is equal to first plus last upon 2, and then if a middle, the item at the middle index is less than the N, means that the item that we are looking for, then move the first to the middle plus 1 index, that I have just explained you. Otherwise, if item at middle position is greater than the item that we are looking for, then the move this last to the middle minus 1. Else otherwise, if this both does not happen, means item is present at the middle, and we will just print that the item position as the middle position, and by break we will come out of the loop. And if first is greater than last, means we reached at the last, first becomes greater than the last, and we does not able to find the element, and then we will write the item is not present in the list. This way we can code the binary search technique. So let's see what will be the output of this program. First message will be there, enter the size of array. We have entered the size 5, and then we entered the 5 elements in the sorted order, because to apply binary searching the lists must be sorted. We entered this sorted elements, and then we asked from the user enter the elements that he or she is looking for. That lets the user has entered 20, and this 20 will be compared with the mid index. The mid index will be found, and by applying the logic that I have explained just below, just above, and this will find, and it will tell that the element is found at position 3. So this way you can apply the binary searching technique. So what is the performance of binary searching? If we can see that at every time the list is subdivided into half part. So the worst running time of the binary search algorithm is log n to the base 2, log n to the base 2. For successful best case, as the linear searching, for the successful best case, the number of comparison is 1 at first mid index position the elements found. For worst case, the running time is log n to the base 2, and for unsuccessful the running time is log n to the base 2. Okay, this way we can analyze the performance of the binary searching. So searching binary or linear searching is complete now. I hope you understand it. Now what the sorting is, we will understand sorting now. We will understand sorting now. So what the sorting is? Sorting means to arranging elements either in ascending order or descending order, and to arrange the elements in ascending or descending order, there are basically broadly, if we broadly categorize sorting, there are two types of sorting. First one is internal sorting and next one is the external sorting. Internal sorting means the number of elements are smaller, we can perform the whole sorting operation by moving the whole elements and whole logic to the RAM of the system, and that type of sorting is called internal sorting. And when the number of elements are bigger, then we cannot move all the elements to the RAM for sorting, we have to move certain some small elements, some smaller number of elements to the RAM and perform the sorting operation. That type of sorting is called external sorting. Basically here we will focus three sorting, that all three are internal sorting, that is bubble sort, selection sort and insertion sort. So what the sorting is? When we maintain a collection of data, many applications call for rearranging the data in certain order. As we have already seen, to apply a binary searching, the data must be in sorted order. So for arranging, the example of sorting is, let us say we wants to arrange the list of students according to their ascending order of their chronicle names. We wants to arrange the list of students according to the chronic order of the name of a student. So sorting refers to arranging a set of data in some logical order, either in ascending or descending. So if the list is unsorted like this, and to apply the sorting, whenever we will apply this sorting and we want to arrange this data in the logically ascending order, then this may be seen like this. When we sort it in ascending order, the list will become like this, and if we sort it into descending order, the list will become like this. So we have given this type of list and we want to convert it by our programming logic into this ascending order or descending order as the requirement of our program. So we will understand these three sorting techniques. First one is the selection sort, next one is the bubble sort, and last one is the insertion sort. These three sorting will be covered over here. So what the selection sort is? I will explain the concept here. Let we have a given set of array, we have given set of elements like this, we have 50, 3, 44, 7 and let us say 40 and 40, and we want, means we have given 5 elements and we want to apply selection sort. To apply selection sort, the position of a element are selected. We select a position, let I have selected the first elements at index 0, and we will compare it with the next element, and comparison and swapping are the single operation. So if we want to arrange this data into logically ascending order, to arrange it, we will when we want to apply selection sort, we will select a position and we will check whether the element of the next element is smaller than this position value. Yes, since 3 is smaller than the 50, means this 50 is greater than this 3, so we will swap it, means now 3 will come here and 50 will move here. Both will be swapped. Means for next iteration we have 3 and 50, 44, 7 and here this is 40. We have this now. We will keep selecting that position. What element is at that position, we have not to take concern of that. So, we will compare this selected position elements to the next one, and if this one is bigger than the next one, means if this one is bigger than the next one, we will swap. Since this is small, we need not to swap. So, that for the next iteration 3, 50, 44 and 7 and 40 are there. We will keep selecting this position and we will compare it with the next element. And if next element is bigger, let I change this last element. Let I change this last element as let I am changing it, this 40, I am changing this 40 to let us say 1. I am changing this to as 1. This one is 1. So, we will check whether the next element is, this next element is bigger, means 3 is smaller than 7. Since it is smaller, first one is not bigger. So, we will not again swap it. Now, we have 3, 50, 40, 7 and 1. Now, position is same, we will compare it with the next element, and if next one is smaller, we will move this 1 to here and 3 to here, means 1. Now, we have 3 over here, 1 over here. We will let us see, when we move this 1 here and 3 to here, means this here 1 will be there and here 1 will, here 3 will come. So, 3 will be here and 1 will move here, and you can see that there is no elements after that position. So, we call it as pass 1. This pass 1 has been completed because no elements are further now. So, we can see that when we completed one pass, the one element at this position are at proper position, means the proper position of 1 is this only. This 1 has arrived at its exact position, means, and we can also see that there are 5 elements at the beginning, and we can see that there are 1, 2, 3 and 4 compare. If elements are 5 in a pass, then there are 4 compare. We can generalize it like, if the number of element in a pass are n, then we have to perform n minus 1 comparison. So, and after one pass, one element will reach to its proper position. So, now we will again move to the next pass, and in next pass we have 1, 50, 40, 7 and 3. We will select the next position now. Firstly, we have selected the first position, and after completing this pass, we see that at this position first the exact proper elements has arrived. So, now we will in the next pass, in the pass 2, we will select the next position, and same logic will be applied. This element will compare with the next one, and if there are not any elements at after this value. So this we can see that we are focusing on 4 elements in this pass, and in this 4 elements we have to compare 3 times. So in each pass, if the elements are in the first pass, if the elements are 5, we have to perform 4 comparison, and in the second pass if the elements are 4, then we have to perform 3 comparison. Similarly, in the next pass we can see that in the next pass, in the pass number 3, in the pass 3 there are, we will focus, we will write 1 and 3, but we will not perform the any sorting logic over here. We will now focus on 50, 40 and 7, and now we will select the next position element, and it will be compared with the next one, and since it is greater, this one is smaller, so a smaller value will swapped. So the list we will write, we keep on writing above element also, 40 will move here and 50 will move here. We will write 7 also. Now this position has been same, it will compare with the next element, and compare and swap are the single operation, means 7, this 7 will move here and 40 will move here. The situation will be like, the situation will be like this, means this 7 will move here and 40 will move here. So here there will be 7 and here it will be 40. So we can see that since there are no element further, so this pass 3 has been completed now, and we can see that when this pass completed, 7 has arisen to its right position, means at this selected position the element, the right position had achieved, right elements has come to this place. So now we have to focus on next 2 elements in the next pass. In the pass 4, we have 1, 3, 7, it has been already sorted. 50 and 40, there are 2 elements. Now we will select this position now, and we will check it with the next one. Comparison and swapping are the single operations, since there are 2 elements, so one single comparison has to be performed, means this 40 and 50 will be compared and swapped. Comparison and swapping are single operation, means 50 will come here, 40 will come to our place. So it will be like this. Let's this here there will be 40 and here it will 50. So here there will be 40 and here 50 will come. So we can see that at this pass completed, this element 40 has arrived to its proper position, and by default this 50 will be at its right position. So you can create an analogy, you can design your analogy that when there are 5 elements we have to perform 4 comparison, when there are 4 elements we have to perform 3 comparison, when there are 3 elements we have to perform 2 comparison, and when there are 2 elements we have to perform 1 comparison. Means if there are n elements in a pass, you have to perform n minus 1 comparison, and if there are n elements, you can see that we have to perform n minus 1 passes also. Means the number of passes, if 5 elements are there, you can see that we have to perform 4 passes, and if there are n elements, so you have to perform n minus 1 passes and in each pass you have to perform n minus 1 comparisons, means in totality you have to perform n minus 1. The complexity of this algorithm will become n minus 1 into n minus 1, means order of n square will be the complexity of your selection sort, will be the complexity of your selection sort. So this is the logic, this is the logic of implementing a selection sort in the list. Let's understand it by the program. Let's understand it by the program. I am erasing all this. So what the selection sort is, that I have already explained you the logic. So this is the program, this is the program for selection sort, and this is, there are very much higher chances of this program to come in your university examination. So you have to keep in mind. So this scanf, here I have declared a array A, here there is a array A, I have declared it, and I have entered the size of this array as n, and then up to n I entered the element in this array, and then I applied. Now I am going to apply the logic. The number of passes, the first, this for loop is for number of passes, and this next for loop in this pass is for number of comparison. So we will use, the number of passes will be from 0 to n minus 1. N minus 1, why? If the n elements are there, the number of comparison, the number of passes will be n minus 1. So this loop of for passes will be up to less than n minus 1, and we will select the elements into the A of I, because we know that since the outer loop will change after the inner loop completes. So in inner loop we will select the next element, and we keep the first element selected position element into the outer loop index value. And so in the comparison loop I have started it with j equals to I plus 1 up to less than n, and we compared it with A of I to A of j. I is 0 and j is I plus 1, means j is 1. So A0 will be compared with A of 1, and if the first element A of 0 is greater than A of 1, we will swap it by applying this logic. Already you know this concept of swapping. We will put A of I to t, A of j will be assigned to A of I, and A of j, in A of j we will assign t. This way you can swap A of I and A of j, and after swapping the j will be incremented and I is same, means j will becomes 2 now. Firstly it is I plus 1, I is 0, means j is started from 1. Now j will become 2, means A of 0 will compared with A of 2. Then j will become 3, A of 0 will compared with A of 3. J will become 4, A of 0 will compared with A of 4, means first selected position element is comparing with all other remaining elements. And this way the same logic of selection sort that I have just explained with the example has been coded like this. I hope you all understand it. I hope you all understand it. Thank you. In the next lecture I will cover the bubble and insertion sort. Okay, and after sorting we will print that sorted array like this. Okay, thank you students. We will meet in the next lecture. Thank you. Thanks a lot.